The power rule for exponents says that when we have the same base and different exponents being multiplied, the result is simply the same base with the sum of the exponents. To see an example of why this makes sense, we can look at this example. B squared times b cubed. Well, what is b squared? Well, it's b times b. And what is b cubed? Well, it's b times b times b. So we get this expression. And notice there's 5 b's, so this is the same thing as b to the 5th. So what we've just seen is that b squared times b cubed is the same thing as b to the 5th. So in general, this is the rule. B to the m power times b to some different power. As long as the bases are the same, the exponents can be different. The result is simply that base to the sum of those different exponents. Looking at this property, b to the 0 times b to the 1, well, if we wanted to try to figure this out, well, we can just add the exponents. So this becomes b to the 0 plus 1, and 0 plus 1 is just 1. So we get that this expression is just equal to b to the 1. But if b to the 0 times b to the 1 is equal to b to the 1, that would imply that b to the 0 must equal 1. The quotient rule for exponents is similar to the product rule, except instead of adding, there is subtraction. So when the bases are the same and the exponents are different or the same, what matters is that the bases are the same. We can rewrite this expression as just a subtraction of the exponents, the top exponent minus the bottom exponent. So to see an example of this, we can look at b cubed divided by b squared. So b cubed can be rewritten as this, b times b times b. B squared can be written as b times b. So of course b divided by b is 1, b divided by b is also 1. So we just get left off with this b. So know that b is the same thing as b to the first power. This is just another way to write it. And now we can see that b cubed divided by b squared is just equal to b to the 1. But that just seems like we just subtracted the top minus the bottom exponents. So in general, we say that b to the m divided by b to the n is equal to b to the top exponent minus the bottom exponent. But of course, this only works if the bases are the same. It has been shown that b to the 0 power is equal to 1 based on this power rule for exponents. Now, using the quotient rule for exponents, we can try to figure out a different property, that b to the negative n is equal to 1 divided by b to the positive n. So trying to see this, we can look at an example. So looking at this example, b squared divided by b to the 4th, well, we know we can rewrite it using this rule here, but let's just try rewriting it standard how we would do it generally. So b squared is just the same as b times b. B to the 4th is equal to b times b times b times b. Of course, these 4 b's just cancel. B divided by b is 1, b divided by b is 1. So we just get left off with b times b on the bottom. Of course, 1 divided by b times b is the same thing as 1 divided by b squared. So this is one way of doing it, but let's try doing it using this rule. So using this rule, the quotient rule for exponents, we get top exponent minus bottom exponent. So 2 minus 4. 2 minus 4 is negative 2. So that would mean that 1 divided by b squared is the same thing as b to the negative 2 power. So in general, we say that if we have a negative exponent, we can always take it to the denominator if we just write it like this, 1 divided by b to the n power.